It's my pleasure to be part of this special online Computex. I'm Albert Guo from Realtek. I'm leading the automotive business unit. For my keynote, I'm going to spend some time to discuss about the challenges and the possible solution for in-vehicle networking. And the automotive industry is facing significant changes. These changes, once a thing of science fiction, can now be seen in automobile showroom. And the customer, they want the car in the future to be more connected, autonomous driving, and be able to share, also electrified. Responding to these changes, the traditional car makers, they develop new strategies, such as launching their plan to stop combustion car production, and such as align with non-traditional company to develop their level 4 autonomous driving car. And we see a lot of innovation toward this direction, which will significantly reshape our lifestyle. Riding the coattail of this 5G adoption and within the context of AI revolution, companies such as Apple, Google, and also Amazon, Cisco, Huawei, Xiaomi, and also Foxconn, I think they are ready to the fray. And let's talk about the challenges, how to achieve this. And from the left-hand side, you can see from customer point of view, they want the car to be more autonomy and to be more safe and reliable. And from OEM, from car maker point of view, they want the car to be able to mass production and able to do some differentiation. But how? A new concept called software-defined car jump out. Software-defined car means the car maker is able to separate hardware and software. By doing this, most of the hardware can be reused and be able to mass production. And the software is able to update from time to time over the air. And by doing this, start from now, a new business model become possible. You can see more cash flow, revenue, after the car been sold. From customer side, they can enjoy fresh, renewed, like new product all the time through the whole car lifetime. Okay, to fulfill this requirement, on the right-hand side, these are the whole challenges. When you design the new EE architecture of the car, this must be considered in the same time, including, say, platform design, and also scalability and flexibility, which enable the car maker to scaling from low entry model to luxury car. And also including the communication must be secure to protect from hackers. And also function safety. We are talking about not just level 2 autonomous driving, but level 4. And to the end, also the most important, the solution must be cost competitive and also power efficient. So this is the biggest challenges. And we see in EE architecture level, those are the big topics. And the good thing is, there is a clear way forward. Let's now look at how the EE architecture evolved, starting moving from left to the right. And in the past, you can see there is no network concept. It's more like point-to-point connection, and this implies a lot of harness and a lot of ECUs. A luxury BMW Mercedes 300 series, they may have up to 150 ECUs. And also they have more than 40 kilogram cable harness. And let's look at today's solution. You can see in the middle, there is a gateway, Ethernet as a backbone. They connect to different domain controller. And with this simplicity architecture, the OEM is able to do platform design. And then let's look at the right-hand side. So there are several zone controllers being reused. This can largely cost down the hardware. And also the harness, the number of ECUs also reduced. So this zonal architecture, we believe they will be the best architecture for the near, say, coming 5 years autonomous driving, because they also have the nature of redundancy. Imagine if any connection of the cable in the diagram has any problem, disconnect, broke, they can go through the other way around to the center vehicle computer. By doing this, you can see the hardware and the software can totally decoupled. And the OEM is now able to update the software, the car features from time to time through the air. So this is OTA. Okay. And I believe this challenge can be well conquered by Ethernet plus zonal architecture and a centralized vehicle computer. Now, car as a part of IoT, you can see a true safe autonomous driving relies on V2X communication. With Ethernet as in vehicle networking, they are unavoidably need to communicate with outside world. So you can see with all IP-based communication, the latency between communication inside outside world can be reduced or even removed. And the latency is very mission critical for high-level autonomous driving. Okay, and then let's see how this gonna cultivate the ecosystem. In November 2011, to cultivate widespread adoption of Ethernet in automotive industry, BMW founded Open Alliance. It consists of more than 10 technical committees setting common standard for all aspects of Ethernet adoption. For example, interoperability test to ensure different vendors' solutions can talk to each other. ECU testing, they make sure different tier 1 supplier solution can be interoperable in the car level. Not mention other like cabling, connector, material stuff. And today, there are more than 340 members in the alliance. And we encourage the industry to participate in this standardization body. Other than Open Alliance, IEEE and ISO, they also play an important role. They set up standards and enable the Ethernet to address the increasing demand for feature sets, for higher speed, different data rate, and also for safety requirement. Okay, so we believe with this standardization, it will, say, cultivate a healthy ecosystem for Ethernet in automotive industry. And it will also boom up the market. And the other thing worth mentioning is safety and security. Safety concerns about human. Security concerns about data. And we are now talking about the level 4 autonomous driving. The higher the autonomous driving level and the overlap of these two topics, the area, the bigger. So I can say there is no safety without security. This security is specific for cybersecurity. And that's, imagine if the hacker were able to remote control your car and cause fatality. Imagine if the hacker were able to hack into your secure system and lock you out, request for ransom. So again, there is no safety without security. So this is also a very big challenge and also very hard topic when we introduce this Ethernet technology into automotive industry. Okay, at the heart of this promising technology, I think it is quality, or you can say reliability. Unlike consumer electronics, averaging the product life cycle is like 2 to 3 years. And for automotive products are expected to about 15 to 20 years. So this is minimum to no room for error. So you can see before the start of production or after the start of production, you can see many other quality management tools. But the most important thing and also the fundamental is the zero defect mindset. So all the participants in the industry, they must keep this zero defect mindset. I'm very happy to say Realtek, with more than 10 million pieces of device shipped, and we achieve this zero defect. And today, we discuss the market trends pushing the automotive industry to adopt Ethernet as an ideal solution to its growing needs. And we have discussed what those needs are at EE architecture level and how the technology, things are moving and evolving, including this software-defined car concept. Okay, we also briefly touch on the importance of security and quality, and also reliability. And before I end today's keynote, I want to impart my audience a final note on why Realtek and how Realtek fit ourselves in the big picture. As you can see from the slide, Realtek offers total solution for automotive Ethernet with scalable and flexible and also future-proof to address the automakers' demands on security, safety, power efficiency, and also increasing bandwidth. If there is any product-specific questions, I would be very happy to discuss with you in a personal level. Thank you.